Hi guys, in this video clip, I'm going to introduce you the concept of risk overweight property investment portfolio. And I will demonstrate how to calculate the risk of that portfolio consisting of two investments. These investments can be property assets or other equity investments. So I'm going to show you in an example. First, let's look at the formula of this risk for a property portfolio. So the chart here shows that in order to calculate the risk of a portfolio, so now we need the information of weighting for each property. And we will also incorporate the information of risk for each property. In addition, the risk of an investment portfolio consisting of more than one assets, we will have an additional term to incorporate. That's the covariance between each pair of properties. So this covariance plays a significant role in risk management. In my previous video, I have introduced the concept and calculation of covariance. So now let's look at the formula for the calculation of risk for a portfolio. So this portfolio, we assume, consists of two properties. And similarly, we have a terminology standard deviation of a portfolio's return. We represent it as a kind of risk for this portfolio. So now with all the above three information, then we can input numbers into this formula. And we can see that, well, we will incorporate the weighting of A raised to the power of 2 times the risk of property A's return and raised to the power of 2. Then we will add similarly the incorporated risk and the weighting for the other property in the next overall term. The last part, the influence of covariance between two properties, they are added in this calculation. And at the end, we will have a square root for the overall term in order to incorporate the overall term into the risk standard deviation. So now let's look at the example. In example 4, in my previous two demonstrations, we have already calculated the risk for each individual property. So that's shown in my previous two video clips. And also we have learned the calculation of covariance between these two properties. So now I'm going to put a note of what we have calculated before, so then we will utilize the formula for the risk of the portfolio. So risk of property A equals, from the previous calculation, it equals around 3.79%. So then we also have risk of property C that we have already calculated as around 2.53%, and covariance. A and C's return series. So the covariance equals around negative 0.096%. So now these are the available information for us. And besides, we do need the information of this weighting of property A and the weighting of property C in the calculation of risk for the portfolio. So now let's move forward to see this. And risk of a portfolio with A and C equals, now we apply the formula that I shown you just now. So overall, we need to have weighting of A that's 50%, right? 50%. And then raise it to the power of 2. I use this symbol to represent the power. Then we will times the risk of property A, that's about 3.79%. So we will have 3.79% raised to the power of 2. Then we have incorporated information of risk of property A in this risk for this portfolio. Similarly, we are going to add the same effect from the risk of property C. So we have weighting for property C, 50%, raise it to the power of 2. Then we have times property C's risk, 2.53%, still raised to the power of 2. Yeah, so now we have, till now, we have taken into account the influence of property A and the property C's risk. The last term, very important. Now we are going to include the cross effect of the property A and the property C's performance during certain market conditions. So this cross effect is denoted under this terminology covariance. So for the last part, as in accord to the formula, we have 2 times the weighting of property A times the weighting of property C, then multiplied by covariance. So that's what we will do. So weighting of A, 50%, times weighting of C, 50%, then times that covariance. And interestingly, we have covariance that's negative. So it's very important to keep this negative term because it will also give us the benefits of risk reduction for this portfolio. So now we have included all the effects, individual properties influence, and plus the co-movement or return series between these two properties as indicated by covariance into this calculation. So the last part, we will take the square root for the overall term. So we will still use this and we input 0.5. So the power of 0.5 to represent square root. And if you use a scientific calculator for the overall formula, this will give you around a number 0.63% for the risk of the overall portfolio. Yeah, so now I'm moving the covariance part over here. Yeah, so this now completes the calculation of risk of a portfolio consisting of 2 investments. The key concept here is that now we understand covariance plays a significant role in risk management. Negative covariance can help reduce the risk, and substantially high covariance can add additional risk to the investment portfolio on top of the individual property's risk. So in my previous video, I have shown you the concept of covariance, and in general, we understand covariance contains the information of co-movement of two return series. If you would like to understand more the application of these formulas and examples under real-world scenario, so review the case study that I demonstrated in class, or follow up for my further demonstration in real-world cases. Thank you very much for your watching.